Okay, I want you to close your eyes for a second. Imagine you're standing in the middle of a massive industrial construction site. It's arguably one of the most chaotic environments on Earth. You've got the noise, the grinding of metal, roar of diesel engines, people shouting, and the dust. You can just feel it coating the back of your throat. It's a complete sensory overload.
It is. But on the kind of site we're talking about today, the visible chaos, that's not even the biggest problem. It's the invisible stuff that keeps you up at night.
Exactly. We aren't just talking about bricks and mortar here. We're talking about high-voltage electricity humming through cables as thick as your arm, running right alongside these massive, complex machines with moving parts that could crush a car in seconds.
That is the definition of high stakes. You're not just dealing with gravity, tripping or falling. You're dealing with hazardous energy, with forces that can kill you before you even know they're there.
And that's the world we're stepping into today. We're looking at a very specific, very intense document. It's a safety training program for an ABM project in Uttar Pradesh, India. And the title alone, it sounds like something out of a military briefing. Electro-Mechanical Site Safety and Operational Command Structure.
It sounds rigid, doesn't it? Command structure.
Yeah.
But honestly, when you're dealing with projects of this scale, rigidity is the only thing that stands between order and, well, tragedy.
That's the mission for this deep dive. We're going to decode this document. And I have to admit, when I first picked this up, I thought, okay, a safety manual, great. I figured it to be 20 pages of wear your hard hat and watch your step. But as I read through it, it really struck me, this isn't just a checklist. It reads like a blueprint for keeping people alive. It's surprisingly gripping.
I'm glad you caught that. It's so easy for people to just glaze over when they hear safety training.
Yeah.
But from a systems perspective, this is fascinating stuff. It's basically a study in organizational psychology applied to physical danger. It's not just about rules, it's about creating a system of survival.
A system of survival.
Yeah, where every single person, from the guy pouring concrete to the engineer, wiring a control panel, fits into this protective grid.
So let's unpack this grid. We have a lot to cover. We need to talk about the specific hazards of electromechanical work, because that's a unique beast. We'll look at the legal frameworks in India, especially this BOCW Act that keeps popping up. And of course, we're going to dissect the organization chart, which seems to be the absolute brain of this entire operation.
The organization chart is key. It defines who is responsible when things go wrong. And that is the single most critical question on a site like this.
Okay, before we get to the who, let's set the scene a bit more. The source specifically mentions a project in Uttar Pradesh. Now, for listeners who might not be familiar, that's a massive state in northern India. You're often dealing with extreme heat, humidity, a very diverse workforce.
Right. And then you layer on this term electromechanical projects. We should probably define that because for those of us who aren't engineers, it might just sound like jargon.
Yeah, paint the picture for us. What does that actually look like on the ground?
It means complexity. You have two dangerous worlds colliding. Electrical means power distribution, substations, live circuits energy that travels at the speed of light. Mechanical means heavy industry turbines, conveyors, hydraulics, physical mass in motion.
So it's not just wiring a house, and it's not just building a static bridge.
No, it's both. And when you combine them, the risks multiply. You're not just worried about a brick falling on your head. You're worried about an electrical fault causing a mechanical malfunction. You're handling heavy steel equipment near live wires. The cognitive load on the worker is massive because the threat can come from anywhere.
The document actually lists those specific risks: electrical shocks, machinery malfunctions, heavy equipment handling. And what stood out to me is how immediately it pivots from here is the danger to here is the armor, the PPE, personal protective equipment prerequisites. Yeah. And we're not talking about a high-vis vest and some sunglasses here.
No, the requirements are much, much stricter.
Yeah.
The source lists things like insulated gloves and arc flash suits.
Arc flash suit. That sounds like something out of a science fiction movie. We hear electrical shock and we think of, a buzz or a zap. But an arc flash is something else entirely, isn't it?
It is incredibly serious. An arc flash is, well, it's basically an electrical explosion.
An explosion.
Yeah. It happens when an electric current leaves its path and travels through the air from one conductor to another or to the ground. It ionizes the air, and the temperatures can reach 35,000 degrees Fahrenheit.
Wait, 35,000 degrees?
That's That is roughly 4 times hotter than the surface of the sun.
And it's terrifying.
It's a blast. It creates a pressure wave that can throw a worker across a room. It can vaporize metal, literally turning copper wiring into gas instantly. So when this document lists an arc flash suit, they aren't being overcautious. They are talking about survival gear.
Right.
If you're working on that site without that specific protection, you are walking naked into a potential firestorm.
That context changes how you read the document completely. It's not just paperwork, it's life support. Now, backing all of this physical gear is a very robust legal machinery. The source references the Building and Other Construction Workers Act, 1996, the BOCW Act, and guidelines from something called DGFASLI.
Right, the Directorate General Factory Advice Service and Labor Institutes.
That is a mouthful. I'm glad you said it, not me.
It is, but here's why it matters. In a place like India, especially on large infrastructure projects, you have a massive mix of labor. You might have highly educated engineers from one state, migrant laborers from another, subcontractors who speak different dialects.
So you have a communication barrier on top of the physical danger.
Precisely. You cannot rely on common sense to keep people safe. Common sense is subjective. It's based on your background, your experience. In a high-risk environment, common sense gets people killed. You need a standardized legal backbone.
And that's what the BOCW Act does. It creates that standard.
It provides the baseline. It says, these are the non-negotiables. It doesn't matter if you're the chief engineer or a daily wage laborer. The law standardizes the safety parameters. It unifies the site.
Okay, so we have the volatile environment, the deadly risks, the rigid law. Now let's get to the brain of this operation. Module 1, organization charts.
This is where it gets really interesting to me. Most people think safety is just about don't touch the red wire. But this document argues that safety is about hierarchy. It's about structure, about knowing who answers to who.
It outlines a very clear chain of command. And sitting right at the top of this pyramid is the project manager.
The project manager. Now look closely at their responsibilities listed here. Overall compliance and resource allocation.
Okay, let's pause right there. Resource allocation.
Yeah.
That's just corporate speak for controlling the budget, right?
Correct. They hold the purse strings.
And overall compliance means they're responsible for safety. Isn't there a massive tension there? The person who has to finish the project on time and on budget is also the one who has to say, stop everything, we need to spend more money on safety.
That is the classic tension in construction management. The eternal struggle between production and protection. And that's why this chart is so important. By explicitly stating the project manager approves safety plans and ensures compliance with the BOCW Act, the document removes the ambiguity.
It's forcing them to own it.
Exactly. It pins the responsibility right on their chest. The document is saying you cannot sacrifice safety for the budget. It is literally part of your job description.
Yeah.
If an accident happens because the budget wasn't there for those arc flash suits we talked about, the arrow on the chart points directly to the project manager.
It's a heavy burden. But practically speaking, the project manager is often in an office looking at spreadsheets. They aren't the ones walking around checking gloves every 5 minutes. That's the next person on the chart, the site safety officer.
Right. If the project manager is the strategist, the site safety officer is the tactician. The source says they manage risk assessments, incident investigations, and, this is crucial, electrical safety audits.
I noticed that detail. It mentions testing insulated tools. That seems really specific for a high-level chart.
That's a great example of the electromechanical focus. In a normal office, if your stapler breaks, it's annoying. On this site, let's say you have a pair of rubber-insulated gloves rated for 11,000 volts. If those gloves have a tiny pinhole in them, a hole you can't even see, they aren't a safety device anymore.
They become a conductor.
Exactly. The electricity will find that path of least resistance right through the pinhole and into your hand. It becomes a death trap. The safety officer's job is to audit those tools. They're the ones conducting the air pressure tests on gloves, checking the mats, making sure the gear actually works.
I like to think of it this way. The project manager is the general back at base, looking at the big mat. The site safety officer is the drill sergeant, walking the lines, making sure your boots are tied and your helmet is strapped.
That's a fair analogy. The safety officer is the enforcement arm. They're the ones who have to be the bad guy sometimes. They have to be willing to stop work if they see a violation, even if it makes everyone groan because it slows things down.
But the chart doesn't stop there. We have to move down to the nervous system of the site, the people who are actually plugging things in and turning things on, the supervisors.
Supervisors are the link between the plan and the reality. The source says they oversee specific teams, electrical crews, or mechanical crews.
And their tasks are very specific, monitoring safe wiring or machinery operation.
And providing on-the-job guidance. That is key. You can train someone in a classroom, but when they're staring at a tangle of wires in the mud, they need a supervisor to say, no, not like that, like this.
It's real-time correction.
Exactly, because in this kind of work, you often don't get a second chance.
And then finally, we get to the workers and subcontractors. I found this interesting. The document doesn't treat them as passive. It says they must report hazards directly.
That is the escalation part of the command structure. It empowers the worker. If a subcontractor sees a frayed cable or hears a weird grinding noise in a gearbox, they aren't supposed to just ignore it. The system demands they report it.
Let's talk about the specific procedures mentioned for them, because this is where the electromechanical part really shines. It lists lockout-tagout procedures.
This is one of the most critical safety concepts in industrial work. If you take one thing away from this deep dive, let it be the importance of lockout-tagout, or LO2.
Break it down for us. What is it?
Okay, imagine you're repairing a massive rock-crushing machine. You have to climb inside it to fix a jammed gear. You're in the dark, in the belly of the beast. While you're inside, someone else, who doesn't know you're in there, walks up to the control panel 50 feet away.
I can see where this is going.
They look at the panel, see the machine is stopped, and think, oh, this is supposed to be running. I should turn it on.
That's a nightmare scenario.
It is horrific. And it happens. Lockout prevents that. Before you climb in, you go to the main power switch, you turn it off. Then you put a physical padlock, your own personal lock, through the switch. You lock it in the off position, and you keep the key in your pocket.
So the machine cannot be turned on until you come back and remove your lock.
Exactly. It controls hazardous energy. It removes trust from the equation and replaces it with physics. The switch is physically blocked. You are safe because you hold the key.
So it's not just a rule, it's a physical barrier. That's powerful.
It's a life-saving protocol. And the source specifically highlights this. On the mechanical side, it mentions guarding moving parts.
Which seems simple. Put a cage around the spinning blade.
Yeah.
But on a complex site, those guards often get removed for maintenance
And forgotten, precisely. And if we connect this back, if a worker sees a machine where the guard is missing, the organization chart dictates what happens. The worker tells the supervisor. The supervisor fixes or alerts the safety officer. The information travels up the nervous system so the accident doesn't happen.
It's a feedback loop. But for a loop to work, people have to know how to use it. Which brings us to the final piece, the training mechanism. How do they actually get this info into people's heads?
The logistics are pretty specific. It's a 4 to 6 hour session.
That's a long time to sit in a construction trailer in the heat.
It is, but notice the methods. It's not just a lecture. The source lists group discussions, demonstrations, and quizzes for retention.
Demonstrations. So they're actually showing how to use the gear, right? Not just pointing at a slide.
You have to. You can't learn how to put on an arc flash suit from a PowerPoint. You have to feel the weight of it. You have to practice the lockout procedure physically, click the lock, turn the key. It builds muscle memory.
And the goal listed here isn't just pass the test. The source explicitly says the objective is promoting a culture of safety compliance.
That word culture is the holy grail. Rules are what you follow when the boss is watching. Culture is what you do when nobody is watching.
That's a powerful distinction.
It is. Culture is what makes a worker stop and say, wait, I don't have my tag on this switch. Even at 3 a.m. when they're tired, everyone wants to go home, and cutting a corner would be so easy. If you can build that culture, that's when you actually save lives.
And look at that emphasis on retention. In this field, if you forget a historical date for a test, you get a B. If you forget to test your insulated gloves, the consequence is immediate and physical.
There is no margin for error. That's why they use quizzes, interactive elements. They need to verify that the information stuck. It's not about checking a box. It's about ensuring the data was downloaded into the worker's brain.
So what does this all mean? We've looked at the hazards, high voltage, heavy machinery. We've looked at the law, the VOCW Act, and we've looked at the people.
To summarize, this document is trying to impose order on chaos. It transforms a construction site from a place of potential disaster into a structured grid of responsibility. It acknowledges the work is dangerous. Electromechanical work is inherently risky, but it argues that with the right structure, those risks can be managed.
It's impressive. It really is a command structure. It gives everyone a rank and a duty in the war against accidents.
And it emphasizes that safety isn't one person's job. The safety officer audits, sure, but the manager allocates resources, the supervisor guides, and the worker reports. If any link in that chain breaks, the whole system fails.
It does leave me with a final thought, though. We've been praising this structure, this perfect hierarchy on paper. Every hazard is reported, every tool is tested, every lock is tagged.
Ideally, yes, that's the goal.
But here's the provocation for you, the listener. We know that in the real world, strict hierarchies can be intimidating. The source outlines a perfect system. But if the command structure is too rigid, does it actually encourage a worker to speak up to a supervisor? Or does it make them fear the chain of command?
That is the million-dollar question.
Does a rigid structure account for human error in the heat of the moment? Does it empower the little guy? Or does it just give the company someone to blame when things go wrong? It's one thing to draw a chart. It's another to make a human being feel safe enough to stop a multi-million-dollar project because they see a loose wire.
That's where the culture objective comes in. The chart is the skeleton, but trust. Trust is the muscle. Without trust, the skeleton just collapses.
Something to think about the next time you walk past a construction site. There's a whole invisible world of command and control keeping that chaos at bay. Thanks for diving deep with us today.
Stay safe out there.